Matrix equations are closely related to matrix vector products. Here we see a matrix multiplied by some unknown vector, and we see the result of that matrix vector product. Okay, so we know the output of taking the matrix vector product, and we know the matrix that we started with. We want to know all possible solutions. I want to point out that this expression makes sense. On the left-hand side, we have a matrix vector product. This is a 3x2 matrix that we're multiplying by a 2x1 vector. Notice that the number of columns matches the number of rows. So these guys match up. So that means that this matrix vector product is defined. It's going to make sense. The result is going to be a vector with 3 entries, because we're taking linear combinations of the columns of this matrix, and each of those columns has 3 entries. So let's calculate the matrix vector product that we see here. We have A times 1, 5, negative 3. So A times the first column plus B times the second column. And we know what this is equal to, right? This is equal to 1, 1, 11. Now we've seen this kind of problem before. In order to find A and B, these unknowns, we can, this corresponds to a system, of course, right? This gives us that A, 5A minus 2B, negative 3A plus 7B is supposed to be equal to 1, 1, 11. So we have 3 equations. A is 1, 5A minus 2B is 1, minus 3A plus 7B is 11. And we can solve this using an augmented matrix. So our columns, our vectors here, 1, 5, negative 3, and 0, negative 2, 7 become the columns of our matrix. These are the coefficients of our unknowns A and B. And our augment is this right-hand side, the vector 1, 1, 11. Okay. We're going to begin by getting rid of the non-zero entries that live below this leading term of 1. Okay, so for example, this 5. So I'm going to replace row 2 with row 2 minus 5, row 1. Okay, so this gives us 0, negative 2, negative 4. All right, next up, we want to get rid of this negative 3 that lives below that first leading entry. So we'll accomplish this by replacing row 3 with row 3 plus 3 times row 1. So this gives us 1, 0, 1, 0, negative 2, negative 4, 0, 7, 14. Okay. Okay, and a little bit more work, which I've written out here, produces a augmented matrix. It's in reduced row echelon form. We have our leading entries moving down and to the right. Above and below each of these leading entries, we have all zeros. And we can write out ours. We can interpret this. We can write out our solutions. This tells us that A equals 0. A equals 1 rather. And that 1 times B equals 2. And this final equation tells us that 0 equals 0, which is true, but not that it doesn't limit things. It's not very insightful. So we have a single solution here. the vector AB was equal to 1, 2. So we had this matrix vector product, and we were able to find this unknown vector that when we multiplied by the matrix produced the entry or the vector 1, 1, 11. Because this corresponds to a system of equations, we might have 0 solutions, we might have this single unique solution, or we might also see infinitely many solutions. We're going to try one more example of this type of problem.